Hi guys, this is Achyut. So we are going to be solving today's LeetCode question, which is majority element. So the question states that we are given a array nums of size n, and we need to find the majority element which is present in the array. The majority element which appears more than n by 2 times. You may assume the majority element always exists in the array. Uh, as the question states that we'll be given an array which will be 3, 2, and then 3. If we observe the array, the three element which exist more than 3 by 2 times. Let's say 3 by 2 will be 1, and then the number of times 3 exists is 2. As 2 is less than 2 is greater than 1, we can say that 3 is the majority element. So we need to solve this in different approaches. Suppose let's find let's find the frequency of every number which is present in the array. Let's take n equal. Let's take a map, and then we'll store int and then frequency of each number present in array. Map will store the frequency of each number present in the array. Suppose let's say this is a given array, then the map will be 3 and 2, and then again 2 and 1. Why? Because the 3 exist twice and then 2 exist only once. So this will be the frequency map, and then if we go through each element in the map, we can find the frequency, the maximum frequency, and then we can return the number present in the map. So suppose if we do via this approach, we'll take the map and then we'll be using the extra space of big O of n, and then time complexity will be big O of n, and if we use map, it is going to be log n for insertion of the elements, and then to see whether it is present or not. If we use unordered map, then it is going to be big O of n itself. But as we are using the extra space which is big O of n, we should optimize the big O of n space as well. So we should optimize in space. So let's take again how can we optimize this particular problem. Let's count the frequency of one particular number, which is majority element, which will be, let's say, f1, and then count frequency of all other elements in array. This will be f2, equal to f2. If we can check this, f1 plus f2 equal to the number of elements present in the array. As it is mentioned that f2 will be always greater than or equal to greater than n by 2, then we can say that this will be f1 equal to n minus f2, and then f1 will be greater than n by 2. So if we substitute here, n minus f2 will be greater than n by 2. and then n by 2 will be greater than f2. So n by 2 will be always greater than f2, and then f1 will be greater than n by 2, and then n by 2 will be greater than f2. So this is the inequality which we had got. Suppose we'll let's count the frequency of all the numbers, and then whenever we see other elements which is f2, we'll try to minus the f1, and then if we see again the frequency with 1, then we can say that it is the maximum element. Suppose let's say we got 3 here. Let's say 3 and then 2 and then 3. Now the number will be 3, number equal to 3, and then count will be 1. And if we move to second iteration, then number will be 2, and then count becomes again 1. Why? Because we'll reduce to 0, but if we reduce to 0, then also we can say that there is at least one number with 2, and then the count is 1. And if we move to the next number, then number becomes 3, and then count becomes 1 again. So we can say that this count is greater than 1, greater than 0, then we can say that this is a particular number which we want. So let's write the code. So number will be, let's say, minimum, and then count equal to 0, and then for all the elements which are present in the nums, we'll go through all the elements. If number equal to nums of I, then we can say that count will be increased, else count will be decreased. Suppose let's say we got count to less than or equal to 0, then we can say that at least the frequency will be 1, that is the last element. So we can say that count equal to 1 and number will be nums of I, and then at last we are going to return number. Yeah, this is a solution. We are just going through all the elements which are present, and then if it is equal, then we are going to say the count will be increased, and if it is not equal, then we are going to say the count will be decreased. And then when it decreases less than or equal to 0, then we can say that this is the number which will exist at least with the frequency of 1, that we are assigning the number equal to nums of I, and then at last we are returning the number. So let's run this. Yeah, let's submit. Yeah, thanks for watching the video.